Okay, and just another note about the pre-recorded lectures. I put a link in Blackboard, and I'm not quite sure if those links are working or not. Some students were saying they couldn't view them. The links, they took them to dead ends. So I want to bring up my screen for 1 second. I'm going to make sure I'm doing this the right way. All right, and in order to access the videos, once you're in Blackboard Collaborate Ultra, you'll simply click the 3 parallel bars, and you'll see a tab that says Recordings, and all of the recordings can be found here. Okay, I know it's a little bit tricky to get to, but as far as the recordings, you can find them within those 3 little parallel bars, and you should find them under Recordings. Okay. All right, so I believe I'm back to my shared camera, my document camera. And someone asked about the very last problem in section 1.4. We didn't actually go over that in class, but I'll show you where you can actually find a tutorial on that. I'm going to go back to Blackboard, and I may have to open this up on a new window. Okay, and it's not actually giving me the links on the side. Okay, give me 1 second as I navigate through the windows. Actually, in this lecture notes section, and I'm going to actually get into our course, Math 110. In this lecture notes section, if you look in chapter 1, section 1.4, there is a regression video, and this video explains how to find the linear equation if you're given a set of data points. Now, as far as that very last problem in section 1.4, you won't actually see that on the test. Okay, so I wouldn't be worried about that one as far as a test question. But again, if you go into section 1.4 in the lecture notes, you should see a regression video. Okay, and that video, I believe it's about 5 or 6 minutes long. Okay, so that will help with problem number, the very last problem 1.4. If you're still having questions, just send me an email. Okay, we can kind of work through that one. I'm going to bring up the section 1.5 notes. And in 1.5, we're going to review linear equations and inequalities. And here's just a little bit of background information about a linear equation. An equation is just a statement that sets two things equal. Okay, every equation must contain equal sign. Expressions don't contain equal signs. If it has an equal sign, that means you can solve it. The solution is the equation that makes both sides of your equation true, and a solution set will be a list of solutions. Okay, now as far as the slides are concerned, this slide just shows the addition and the multiplication properties, but I'm going to go back to the document camera, and we're going to talk about the 6 steps to solve a linear equation. All right, these things may or may not be familiar. So here are the 6 steps to solve any linear equation. Now keep in mind that a linear equation would be any equation that has variables that are not raised past the first power. Okay. I'll kind of go in further detail into what a linear equation is in a sec. But in order to solve a linear equation, the first thing you want to do is remove any fractions. And you remove any fractions by multiplying both sides by the least common denominator. Next, you want to remove parentheses. So in order to remove parentheses, you use the distributive property. And I'm actually going to jot that in there. To remove any fractions, you would multiply both sides, so I'm abbreviating that, both sides by the LCD. Okay, we're going to look at an example containing all of these things. So first step is to remove fractions. Second step is to remove parentheses. The third step, you want to combine like terms. So remember, like terms are the same number raised to the same variables. You want to use the addition, subtraction property of equality. So in a nutshell, what that says, if you add or subtract some quantity from one side of your equation, you must add or subtract that very same quantity from the other side. The same thing goes for multiplication and division. That property of equality says whatever you multiply or divide by on one side, you must do the exact same thing on the other side. And then the last step is to check. So in this first section of today, we'll just take a look at using these 6 steps to solve some linear equations. So now when I say linear equation, I want to go a little bit into further detail. So a linear equation here's just some examples. 2x plus 4 is equal to 6. Right? This would be a linear equation in one variable. So this is a linear equation in one variable. Okay. So keep in mind, as I look at my problem, I don't see any variables that are raised to more than the first power. So this is a linear equation in one variable because there's only one variable and it's x, and it's raised to the first power. The second example, this is a linear equation in 2 variables. So this is a linear equation in 2 variables. Okay. So here's what that 2 variables means. We actually do have 2 variables. There's an x variable and a y variable. Keep in mind that these 2 variables are raised to the first power, and that forces them to be linear. Okay. And then I guess I'll take a look at a third example. You can also see a linear equation in 4 variables, 5 variables. So here's what a linear equation in 3 variables will look like. 4x plus 2y minus, and I'm just making these equations up. Okay, so notice I have three variables. Each variable is raised to the first power. There's no squares or cubes or anything. So this is a linear equation in three variables. Okay. All right, so let's take a look at solving some linear equations using the 6 steps. So for this first example, we will solve and this is actually similar to 1.5 problem number 3. So when you see me write these little digits, 1.5.3, this comes out of section 1.5, and it's actually the third problem in your homework set. And we're asked to solve 3x minus 1 is equal to 2x plus 3. And we're basically going to use those 6 steps we talked about. So the very first step, we would remove any fractions, which we don't have. The second step, we would remove any parentheses, which we don't have. The third step, we would combine like terms. And I guess I should be a little bit more specific here. Combine like terms on each side. So this equal sign splits my equation up into 2 halves. I have a left-hand side and a right-hand side. If I were to look at the left-hand side, I can't combine any terms, right? Because these two terms are different. Also on the right-hand side, I can't combine anything. So I would not use the third step. Now, before you get to the 4th, 5th, and 6th step, you may or may not want to set a guide. So here's what I mean by a guide. I'm going to write V equals to C. So what this means is from this point, you want to try to put all your variables on one side and your constants on the other. Or you could put your constants on one side and the variables on the other. All right, there is no right or wrong to this, but normally you'll put your variable on the left and you'll push everything to the right. So I'm actually going to set a little guide for this problem. I'm going to set it as V equal to C. So this is going to help me as far as to keep straight which things go on which side. So on the left-hand side, I only want variables, and on the right-hand side, I only want constants. So if I look at my guide and compare that to my equation, on the left-hand side, I only want variables. 3x is a variable, so it's okay on the left-hand side. However, -1 is not a variable, so I'm going to move it or transpose it to the other side. So I'm actually going to write this step in. So I have 3x minus 1. So in order to move it to the other side, I'm going to add 1 to both sides. So the properties of equality tell us whatever we do to one side, we must do the same thing to the other side. All right, so notice I added 1 to both sides. On my left-hand side, my 1's will cancel. So I'm left with 3x. Okay, and that forces my variable on the left. And now I want to simplify my right-hand side. So I can only combine like terms. So I'm going to bring down 2x. 3 plus 1 is 4. So if I look back at my guide, I only want variables on the left. So this 3x is okay. However, on the right-hand side, I only want constants. 2x is not a constant, so I'm going to move it or transpose it to the other side. Now, when you hear me say transpose, that simply means you would take your term, you would just stick it on the other side of the equation and make it negative. And that would automatically force it to cancel on the side that it's on. So I'm going to subtract 2x from both sides. So I'm going to transpose this 2x. So I'm going to move it to the other side, but I'm going to change my sign. So the 2x on the right becomes negative 2x on the left. And I'm going to bring down 4. So now I'm going to combine like terms. 3x minus 2x is x. And we have our solution. X is equal to 4. So now I actually did a couple of things on this problem. The first thing I did was I used the property of equality, where you saw me physically add the same quantity to both sides. For this second part, I could have used the subtraction property of equality, right? I could have subtracted 2x from both sides. But in this case, I did what's called transpose, and I simply moved my 2x term to the other side of the equation, and my sign changes. So I transpose 2x, and then I solve for x equal to 4. All right, now here's how you check, and checking is optional, but just to show the check step. In order to check, I want to go back to my original equation, which is 3x minus 1 is equal to 2x plus 3. And I want to substitute x for 4. So is 4 the magic number that makes both sides equal? Well, I'm going to substitute x for 4. And I'm going to simplify. So 3 times 4 is 12. Bring down my minus 1. On my right-hand side, 2 times 4 is 8. So on my left side, I have 11, and also on my right side, I have 11. So I know my value 4 is a solution. All right, so any questions about that problem? All right, let's take a look at a problem that is similar to, this is 1.5, number 4. And we're asked to solve 3x plus 7 over 2 plus x minus 7 over 3 is equal to 17 halves. All right, and we're going to use the 6 steps. So the very first step says we have to remove fractions by multiplying by the least common denominator, or that can be the least common multiple. So I'm going to dovetail on this a little bit, and I'm going to write or LCM. Okay, the least common denominator and the least common multiple are one and the same. So now how do I find the least common denominator or least common multiple for this problem? Well, I'm going to use this multiple concept for a second. The multiples of, let's say, 2 would be 2, 4, 6, 8, 10, 12. So up here I'm going to put multiples. And I'm using 2 because 2 is my denominator. So my multiples of 2 are 2, 4, 6, 8, 10, and that'll keep on going forever. My next denominator is 3, so I'm going to find all the multiples of 3. So the multiples of 3 are 3, 6, 9, 12, keep on going. So the only thing I'm doing is I'm taking my number, I'm multiplying it by 1, I'm multiplying it by 2, multiplying by 3, multiplying by 4, so on and so forth. If I look at my multiples, the least common multiple between 2 and 3 would be 6, which is the same as the least common denominator. So if I go back to our first step, it says to remove the fractions. We're going to multiply both sides of the equation by our least common denominator or least common multiple, which is 6. So I'm going to write that out. I'm going to multiply my left hand side by 6. And my right hand side by 6. All right, so on the left hand side, I'm going to distribute 6. When I multiply 6 times 3x plus 7 over 2, I could distribute 6 by 3x and 6 by 7 and put that over 2. Or I could reduce 6 first. So here's what I mean by that. The 6 divided by 2 would give me 3. So once I reduce, I would actually distribute 3. So I'm actually going to kind of write a 3 here. So 3 times 3x is 9x. 3, because we reduced that 6. 3 times 7 is 21. When I multiply 6 times x plus 7 over 3, the 6 and the 3 reduce to a 2. So I'm actually going to distribute 2. 2 times x is 2x. 2 times negative 7 is negative 14. And on the right hand side, when I distribute 6, or when I multiply 6 times 17 over 2, the 6 divided by 2 will reduce to a 3. And 3 times 17 is 51. So notice that all of our fractions are now gone. So that was the first step. We removed the fractions. We also removed the parentheses in that process. Right, I have parentheses set up. Now we'll combine like terms on each side. So if I look at my left-hand side, I can combine 9x plus 2x. So that's going to give me 11x. I can combine 21 and negative 14. So 21 minus 14 is 7. And that's equal to 51. So we've combined like terms on both sides. So we can set a guide if you choose to do so. I want to put my variables on the left, my constants on the right. So if I look on my left-hand side, I only want variables. 11x is a variable, so it's okay on the left-hand side. However, 7 is not a variable, so I want to transpose it. I want to subtract it from both sides. So I have 11x is equal to 51 minus 7, which is 44. So now I have my variables on one side, my constants on the other side. Now I need to isolate from my variable x. So in order to isolate from my variable x, the opposite of multiplying x by 11 is to divide by 11. So I'm going to divide both sides by 11. And we have x is equal to 4. All right, and here again, you can check this. You would just substitute x for 4, and both sides should equal to 17/2. All right, so the solution here is 4. All right, any questions about the first two examples thus far? All right, I actually want to shift gears for just 1 second. Now, even though this is in section 1.6, right, this is from section 1.6, and this is problem number 10. We're asked to solve Q is equal to 2K plus 2Z. And we're asked to solve for K. And this is called a literal equation. It's a literal equation because I can't actually solve this for K to get a number value because there's too many unknowns. This is actually a linear equation in 3 variables. So since there's too many variables, I can't actually solve it for K, but I can rewrite it with K on the side of the equation by itself. All right, so how do we solve this for K? Well, we're going to use those 6 steps, basically. And right here where we have our guide, the variable on the left, constants on the right, our setup is we only want K on one side and everything else on the other. Okay. So we're going to use these steps in a roundabout way. So the first thing I would do is I would locate K. Right, I have my left hand side, I have my right hand side. K is on my right hand side. So I'm going to just ignore the left hand side for a second. On the side that contains K, there are 2 terms. One of these terms doesn't have anything to do with K. So I'm going to take this term 2Z and I'm going to transpose it or move it to the other side. So what I'm doing is slowly but surely isolating K. So my first step is to transpose 2Z. So once we transpose 2Z, we have Q minus 2Z is equal to 2K. All right, so lastly, in solving for K, right, I'm solving for K, not for K. So the opposite of multiplying K by 2 is to divide by 2. So I'm going to divide both sides by 2. And that isolates K. All right, so my final result is Q, and that's supposed to be a Q, minus 2Z divided by 2. All right, so this would be my final answer. Now, normally, some tendency would be to cancel the 2's, which is not possible, right? This would be your simplified answer. Okay, so this is called solving a literal equation. All right, now we'll take a look at solving a linear inequality. All right, so now that literal equation problem was from section 1.6. Okay, and you should see a problem similar to that tomorrow. So even though that is in a later section, you actually use those 6 steps. Here's problem number 12 from section 1.5. And we're asked to solve 1 is less than or equal to 4x plus 1 is less than or equal to 13. All right, so this is called a compound inequality. And in a compound inequality, right, we have 2 inequalities. Our goal is to isolate for x in the middle. So once we're finished, we only want x in the middle. And one thing else I should add, we want to write the solution in interval notation. Okay, so we'll talk about that. We'll take the last part, we'll actually use the interval notation we talked about last time and convert this from set builder notation to an interval notation. All right, so almost like in the literal equation from the previous example, I want to push everything from outside of the innermost inequality, and I want to leave x in the middle. All right, so if I look in the middle, I have 4x plus 1. In order to isolate for x, the first thing I'm going to do is I'm going to transpose 1. So I'm going to subtract 1 basically from all 3 sides. So I'm going to write this out. 1, and I have minus 1. 4x plus 1 minus 1, and 13 minus 1. So whatever you do to one side, you must do the same thing in this case to all 3 sides. So 1 minus 1 is 0. I'm going to bring down my inequality. The 1's will cancel in the middle. And 13 minus 1 is 12. Lastly, the opposite of multiplying x by 4 is to divide by 4. So I'm going to divide everything by 4. And now I'll simplify. So 0 divided by 4 is 0. So just a note on this. Okay, this is just a side note for some facts. 0 divided by any number is 0. Any number divided by 0 is undefined. So you can't divide by 0. So I'm going to put a little stipulation to this. A can be any number, and this is what you'll see oftentimes on these formulas. A cannot equal to 0. So 0 over any number except for 0, because 0 over 0 is undefined. All right, so 0 over any number except for 0 is 0. If 0 is in your denominator, then your number is undefined. All right, so 0 divided by 4 would give us 0. The 4's will cancel, and that isolates x in the middle. 12 divided by 4 is 3. All right, now for the last part, how do we write this in interval notation? So since this is a compound inequality, we're actually given two inequalities in one statement. So normally when we write out our inequalities are normally on the left, right? However, if I look at the first part, my variable is on the right. You can rewrite the first part. 0 is less than or equal to x is the same thing as x is greater than or equal to 0. And then I have my second part of my inequality, x is less than or equal to 3. So based on what we did before, I'm going to make a rough sketch of a graph. I'm going to set at 0 and 3, negative infinity to the left, positive infinity to the right. So remember, for our first part of this inequality, x is greater than or equal to 0. Since I have my equal to bar, I'm going to use a bracket. That bracket should face the right, and our line should extend toward the right, because we want all numbers greater than or equal to 0. And at the same time, x is less than or equal to 3. Since I have an equal to bar, I'm going to use a bracket at 3. That bracket should face the left because we want all numbers less than or equal to 3. The line should also extend to the left. So this is my interval notation solution. It's the closed interval from 0 to 3. So remember, your interval notation must always follow a number line from left to right. The smallest quantity must be on the left, the biggest quantity must be on the right. All right, so any questions about section 1.5? They were using the 6 steps to solve a linear equation. All right, now in the last section, we will take a look at some applications. And I'm going to go back to the shared screen. All right. Okay, so I think we covered everything in this 1.5 section. So in section 1.6, it's just some steps to solve an application problem. It says read the problem, make sure you understand it, assign a variable to what you're being asked to find. If necessary, write other quantities in terms of the variable. Then you want to write out an equation. You may need to sketch a diagram to refer to known formulas. You'll then solve the equation, and then you'll check. All right, so let's take a look at an example of solving a application of a linear function. All right, so here is problem number 3 from 1.6. And it reads as follows: a rectangle has a width of 44 centimeters and a perimeter of 194 centimeters. What is the the length. All right, a rectangle has a width of 44 centimeters and a perimeter of 194 centimeters. What is the length? All right, so just to give everyone a second to write that down. All right, so let's review a rectangle. So we'll kind of draw the sketch. Normally in the problems, if there's a formula required, they would give you the formula. And then in some problems like this one, there is no formula. So we're just going to review a rectangle. So in a rectangle, it's basically a quadrilateral figure where the opposite sides are parallel and congruent. All right, so in a rectangle, this was my length. I'm going to call that L. And this is my width. When we talk about the perimeter, would give me the distance around my object. So if this side is L and this side is L, when I add those two sides, I would get 2L. Since this side is W and this side is W, I can add these two sides to get 2W. And this is how we will find the perimeter. We would just add up all the side lengths. You could also find the area. The area of a rectangle is the length times the width. I'm only going to concentrate on the perimeter because I'm actually given the value of the perimeter. So I'm going to just use this formula in our sketch, and I'm going to just plug in and give it information. So it says a rectangle, which we sketched out below, has a width of 44 centimeters. So I'm going to take the width and I'm going to set that equal to 44. We don't know the length. We're asked to find the length. But we're also given the perimeter of 194. So I'm going to substitute those given values into my formula. So I'm given my formula, perimeter equals to twice the length plus twice the width. I'm going to substitute the perimeter for 194 and the width for 44. And I'm going to solve it for L. So my perimeter, that's 194 centimeters. Okay, so I'm going to do away with the centimeter unit for now and attach it at the end. That's equal to 2 times L, which I don't know, so I'm going to bring down 2L, plus 2 times W, and W is 44. So notice in my original equation, I had 3 unknowns, right? For this original formula, you don't know perimeter, you don't know the length, you don't know the width. Once we substitute in the perimeter and once we substitute in the length, notice that there's only one variable, and now we can solve for that one unknown. So since this is a linear equation, you would use the 6 steps. Okay, the first step says remove fractions. We don't have any fractions. The second step says remove parentheses, so I'm going to multiply. So I'm going to bring down 194, bring down my equal sign. I want to bring down 2L. 2 times 44 is 88. I can't combine any terms, any like terms. There's no like terms on the left-hand side, no like terms on the right-hand side. So just to review back to these steps. All right, so I can set a guide, right? The guide I'm going to set here is normally we would put the variables on the left, constants on the right. The way you set your guide will depend upon how much work you have to do as far as manipulating it. So for this example, since I only have one variable and it's on the right, I'm going to let it stay on the right, and I want to put my constants on the left-hand side. All right, so if I look back at my guide, on the left-hand side, I only want constants. 194 is a constant, so it's okay on the left. On the right, I only want variables. The 2L is a variable, so it's okay on the right. However, 88 is not a variable, so I'm going to transpose it to the other side. So 194 minus 88 should give us 106. That's equal to 2L. And now I can solve for L. The opposite of multiplying L by 2 is to divide by 2. And if I divide both sides by 2, 106 divided by 2 is 53. And that should equal to L. So to answer the problem, the length should be 53. All right, so I'm just going to see if this checks out. So if I were to add up all four of my sides, 53 plus 53 plus 44 plus 44, those things should sum to give me 194 centimeters. All right, so on the calculator, I'm going to take 53 plus 53 plus 44 plus 44, and notice we get 194 as a perimeter. All right, so any questions about this problem? Okay, you will see something similar. All right, I'm going to go back to the shared screen. Okay, and for the last slide, it talks about direct variation. And we're given a formula. It says that a number y varies directly with x if there is a non-zero number k such that y equals to kx. The number k is called the constant of variation. Sometimes you may see these things written out as direct variations or direct proportion. You may even see something that says indirect variation or an indirect proportion. So I'm going to go back to the the document camera to elaborate on these, and then we'll take a look at an example. Okay, first we'll take a look at a direct variation or a direct proportion. Okay, so both of these things are one and the same. Some problems may say direct variation, and other problems they may say direct proportion, but they're all talking about the same thing. In order to have a direct proportion or a direct variation, you have two quantities. Both quantities must either rise or both quantities must fall. So I'm going to put a little star, and for a direct proportion, both quantities must either rise or both quantities must fall. So here's an example. Let's say we have the cost and the number of apples. Right, so we have two quantities, the cost and the number of apples. Let's say that 4 apples cost $1. All right. If 4 apples cost $1, how much would 8 apples cost? Well, let's see. If 4 apples cost $1, each apple costs 25 cents, so that'll be another $1, so that'll be $2. 12 apples would be $3. So here's what I want to show here. Both of my quantities are doing the exact same thing. This quantity is going up 4, 8, 12. This quantity is going up $1, $2, $3. You could also have both quantities to go down. All right, but they would both have to do the exact same thing. And that's a direct proportion or direct variation. All right, so now I'm going to split the page. Well, I guess before I split the page, whenever we talk about a direct variation or a direct proportion, this is what's called the model form. Y equal to K times X. And this is the model form. So that just means when we're asked to solve direct proportions, we want to use this equation. All right, here is an indirect variation or an indirect proportion. Or sometimes you may see inverse variation and you may see inverse proportion. All right. So we'll start by this. For an indirect proportion, one quantity rises and the other falls. So notice now this is different than a direct proportion. Okay, a direct proportion, both of your quantities are doing exactly the same thing. They're either rising or falling. For an indirect variation or indirect proportion, one quantity is going up, the other quantity is going down. So here is an example. We're going to put number of men, or I should say number of people, and hours to landscape a property. So we'll take the property, let's say Aiken Tech. So we have one quantity, which would be the number of people, and we have another quantity, which is the hours take to landscape a property. So let's say it takes, and I'm just making these numbers up. Let's say it takes 2 people 8 hours to landscape Aiken Tech. Let's say it takes 4 people. Should take them less time, right? So let's say it'll take 4 people 4 hours. So if we look at these quantities, This quantity is going up from 2 to 4. This quantity is going down the number of hours from 8 to 4. So this would be an example of an inverse variation. One quantity is rising, and the other quantity has to fall. If you're dealing with an indirect variation or indirect proportion, the model form is y is equal to k divided by x. All right, so let's take a look at an example. All right, so this is just to understand what these proportions are and how they operate. All right, so this is coming from section 1.6. This is problem number 7. And we're asked to find the constant of variation which is k, and the undetermined value in the table if y is directly proportional to x. All right, so we're going to be asked to find the constant of variation, which is k, and the undetermined value in the table if y is directly proportional to x. So here's the table. We're just given an x and a y table, and we're given these values for x. 3, 8, 11, 13, and for y we're given 6, 16, 22, and a question mark. All right, so just a few things before we begin. So notice that this is a direct proportion. So notice for x, my values are going up 3, 8, 11, 13. Notice for y, my values are going up 6, 16, 22. So this is a direct proportion. So anytime we deal with a direct proportion, our model form is y equal to k times x. All right. So what we're asked to do is we're asked to find k in this model form. And once we find k, we'll use that to find this undetermined value in the table. All right, so the first thing we're going to do is find k. So how do you find k? Well, we're going to use the model form. Y equals to k times x. And in order to find k, I simply have to stick in an x and a y value and solve it for k. So if I look back at my table, you want to choose an x and y value. But you want to make sure you want to choose a corresponding x and y's. I can either choose 3 and 6, 8 and 16, 11 and 22. I'm going to choose a 3 and 6. So I'm going to take this model form, y is equal to k times x, and I want to substitute x for 3 and y for 6. And I simply pull those values from my table. So I'm going to write this out as 6 is equal to 3 times k. And now I can solve for k. So the opposite of multiplying k by 3 is to divide by 3. So if I divide both sides by 3, I have 2 is equal to k. So this will be my constant of variation 2. So now I want to find y when x is 13. All right, so the second thing we're going to do is find y when x is 13. So how do we do that? Well, in the previous result, we found that 2 is equal to k. So I'm going to substitute 2 for k in this model form. And that's going to be my constant of, or excuse me, that's going to be my direct proportion equation. So I'm going to write that out as y is equal to 2 times x. And I'm going to use this equation to find x, excuse me, to find y when x is 13. All right, so I'm going to use that equation. I'm going to substitute 13 for x. So y is equal to 2 times x. We're going to substitute x for 13. 2 times 13 is 26. All right, so 2 is equal to k, and y is equal to 26. If I go back and look at my table, since 2 is k, notice I can get the y value by simply multiplying the x value by 2. Right? 3 times 2 is 6. 8 times 2 is 16. 11 times 2 is 22. 13 times 2 is 26. All right, so are there any questions about the last couple of sections, 1.5 or 1.6? All right, any questions about anything in general up to this point? Okay, so we won't meet on Thursday. The chapter 1 test is Thursday. Just as long as you take the test before midnight. Keep in mind that there is a chapter 1 formula sheet that's located in that formula sheet section for you to use. As far as studying for the exam, like I said earlier, all of the problems that are worked out in a virtual class, you may see those problems, just as a hint, you may see those problems on the test. All right, well, I guess if there's no further questions, I'll dismiss class.
I have a question. Is the test like the quiz?
Well, just one thing about this course, the quizzes are normally more involved than the test. I'll kind of put it that way. There are some things on the quizzes that you won't quite see on the test.
Okay.
Now, one good thing to do is if you're going through the virtual lectures, the problem that I'm doing, those would be excellent problems to study for your test.
Okay.
Okay.
Thank you.
All right. Any other questions about anything? Now, has anyone tried to view the recorded lectures from the links that I have posted? I'm just curious. So a couple students said they couldn't access them, so I don't know if there was something I was doing wrong, or if you had.
I looked at them this morning. It pulled up for me.
Okay. I was just wondering if I had them posted right. I didn't know if you actually had to be within Blackboard Collaborate to view them. So, all right. Well, if no further questions, I'll dismiss class and see everyone next week, Tuesday. All right, have a good one.